Good afternoon, YouTube. Today's video is a continuation of F5 integration into Red Hat Advanced Cluster Manager. Or you could say it is a conversation around how can we use F5 running in a management cluster and look and watch all of the worker clusters. So again, this is building on what we've been talking about with regards to the multi-cluster strategy. And so I'm creating this demo for a customer in the UK that contacted me and that wanted to use or is using Red Hat Advanced Cluster Management. And so basically what they've done is they've created a management cluster, the concept of a cluster where they're using exclusively for management of apps. And so the whole conversation is, can I use that management cluster for workload that is of type management? So for example, maybe IPAM, something like maybe traffic ingress or distribution of traffic, or being able to handle active standby with ratios, that kind of stuff. And so I actually floated this question to the product manager of Advanced Cluster Management, and we actually talked about it quite a lot. And so what Advanced Cluster Management have done, the team, is they've actually put out a really awesome scaling guide. And so if you scale the stuff correctly, specifically the management cluster, then potentially you could actually put some deployments, some pods actually in that cluster. And I think that that's the purpose. And so I definitely have a thumbs up there, and I do really appreciate the responses and working with Red Hat on this. So this architecture that I'm presenting today is actually an approved architecture working with product management from Red Hat, from the Advanced Cluster Management team. And so big shout out there. And so this demonstration is how we can leverage, or how we can use F5 and integrate with Red Hat Advanced Cluster Manager or Management, ACM, in OpenShift, in specifically a multi-cluster environment. So this document focuses on really deploying what we call F5 CIS. CIS is really just an orchestrator for the gateway that sits in front of the clusters. And that gateway, which is F5 Big IP, can provide traffic management and send traffic from outside the cluster to any app or pod in the cluster. That could be of HA proxy, that could be of nginx, that could be of a third-party pod like an app pod. It really doesn't matter. You could have a two-tier or one-tier architecture. So basically two-tier would be Big IP to Ingress controller or HTTP router like HA proxy or nginx, or some other type of mesh product like Istio or something else, right? Envoy, could be anything. Or you can go direct to pod, which is a one-tier model, which is basically Big IP to pod like you see here, Big IP directly to Coffee or Teapot. That's of your choice. How can we do that? We can do that because Big IP is able to see the pods. And you might ask me how, and we'll talk a little bit about that. So that's what this demo is all about. So as you can see right here, Advanced Cluster Manager is actually installed on this OpenShift 4.14 instance. So if we go to Advanced Cluster Manager, you can actually see here's the local cluster. This is the 4.14. So this is actually the hub. This is where Advanced Cluster Manager is. And I have brought in a worker cluster or a standalone cluster, which is OpenShift 4.15. So that's really cool, actually, because 4.15 only actually came out on Monday. Was released Monday. I'm recording this on Thursday, the 7th of March. And so you can actually see here it was actually installed yesterday. And so you can actually see here that this local cluster is actually managing this remote worker cluster here. So our goal in this app is to run the CIS as a management, you could call it application. In this case, it's an operator. Run it here, and being able to run all of the pods in the remote standalone clusters. Now, obviously, you can keep on adding these clusters, and you can actually scale the pods across multiple clusters. That's the goal here. So what that means is that if I take a cluster down, I don't affect the way that I am handling the traffic and how it gets distributed, because I'm not touching the management cluster. So for example, I can take down this standalone cluster here, do maintenance on it, and maybe send the traffic somewhere else just because CIS is actually running here. That's what's orchestrating the traffic. And so that's the goal here. So I can keep on adding the clusters. Right now, I'm doing 100% traffic here. But if I add another cluster, then I can do blue-green or active-active. And I can take down one of the clusters and not have to worry about where CIS is running, because CIS is running as a standalone in the management cluster. The management cluster doesn't necessarily get touched, right? It's completely isolated. Maybe it has a firewall in front of it. Maybe it has separate users or separate roles. It's almost like your production management. Maybe it's in a separate place. It just kind of depends upon how you want to deploy it. So this architecture is what I was asked about a month ago from a financial institution in the United Kingdom, and they wanted to know if this is possible. And this is absolutely possible. And you got a thumbs up. You can totally go ahead and do this. And I think that from the folks that I've been talking to over the last couple of months, this is what I would recommend. This is potentially now best practices and kind of using this, whether it's OpenShift, whether it's SUSE Linux, whether it's some flavor of Kubernetes. I think it really doesn't matter. Now, maybe in here, since this is Kubernetes, maybe I can bring a Kubernetes cluster in here and kind of do big IP traffic management between Kube as well as OpenShift, but it's a little bit more difficult because Kubernetes is not adopted ovn-kubernetes, and I think the network stack is the most important. So let's go ahead and take a look at this deployment and how this deployment is deployed. So right now we can kind of see here that we're using the multi-cluster hub. So the multi-cluster hub, this is kind of how you bring in the new clusters. But if I wanted to go to the local cluster, this is the local cluster right here. This is a 4.14 cluster, and this is my management cluster. But if you go and see here, you can go to Operator Hub and you can see the installed operators. So this is right here, 492 of Cluster Manager. So this is how you install Cluster Manager. You install this operator. And then if I go look at my workers, you're going to see there's a deployment here of CIS. Let me change it to the Kube system. So you can see here's CIS right here. So CIS is actually running as a deployment or as a pod in the local cluster, in the management cluster. And if you actually look at the YAML, interesting flavor here. It doesn't kind of show. I'm not quite sure why, but you can see the pod is also running right here as well. So what does that look like? I've actually used a manifest. So if I go to the local cluster, I've kind of used a manifest to actually provision that. You can use the operator or you can use a manifest. Preferably, I just like to use a manifest just because it was easier for me. But here's the most important things here. The most important things is that we're doing cluster IP. So we're not doing node port. We're exposing the IP address of the pod. So we can see the IP addresses of the pod. Here is my big IP. This is the namespaces I'm watching. And this is what we call static route is true, and we're orchestrating for ovn-kubernetes. What does that mean? That means that CIS in this picture, in this architecture, will plumb big IP and provide all of the routing that big IP needs. So let's go ahead and take a look. If we look at big IP, if we go down to the network, we go down to the routing piece, we change that to the tenant, and we make this a little bit bigger, show all. Okay, this is what's really important. So what CIS is doing is it's basically picking up all of the nodes and it's plumbing the networks. And it's basically telling big IP, for you to get to the pod, just route to the node. And the node will then route it within the ovn-kubernetes mesh, which is Geneva. So it's not of type node port. We're not going through kube proxy. It's just simply routing directly to the pod. This is like routing downstream to an app. And so how does big IP know where to route? It has these static routes, and this is all orchestrated through your CIS instance. So CIS is able to monitor all of the clusters and kind of learn the networks and plumb the big IP. That's how it's able to reach. And you can kind of see here the networks. Now, when you install all the clusters, they have to have unique networks. If they don't have unique networks, then you have to use node port, because the default network, unfortunately, is 128, right? So if you're doing an IPI installation, make sure you change that install config and start maybe with 148. You can kind of see how I've incremented it. So based on your nodes. So in my case, I have a 6-node cluster. So that's kind of how far I go. So I start at 128, then 148. So this is kind of how you build out your clusters. The next cluster, I'll probably start at 168, right? This is kind of just how I'm doing it. So I edit that, and that's successful, right? And so I did this yesterday with 4.15. It works perfect. So you can see here, right here, is the worker cluster, and here is the local cluster. So that's kind of how that's working by just enabling that. And so CIS will continuously watch if there's new nodes, and if there's new nodes come online, it will add the route. The second thing is I'm using CIS as a standalone, which is fine. It's running in the management cluster. It doesn't need HA. It's a pod. If anything happens to CIS, it will restart. And it will log everything. I'm doing debug logs, turn this off. Here is the gateway config. So what the gateway config is, think of it as like in Gateway API, you have the gateway config. Gateway configuration specifies the IP address of the route, or the IP address of that FQDN for all routes. It specifies and tells us everything about the remote clusters. And so this configuration is made in the local cluster. So if I go and actually expose, you can actually see here's the local cluster and here's the remote cluster. If I expose this, you can actually see right here. Very simple. Think of this as a gateway, but we haven't added Gateway API. We will be adding Gateway API, but only in CIS 3.0. Or so you can see we're using a simple config map. But in this config map, you have your external cluster. And here's how CIS accesses the remote cluster. It uses kubeconfig, right? Which is pretty standard. We all use kubeconfig today, so you're not exposing anything. All you do is you just copy the remote kubeconfig file from 4.15 to 4.14, so you copy it from the remote cluster to the local cluster, and then you create a secret within Kubernetes. Simple, right? So if you look at my secret files, if I actually go in here and actually do an OC get secret, you can actually see here are the secrets, right? So there's 3 clusters. So this is the secret. So this is what CIS is using. It's using this secret. And in this cluster, this is the 414 cluster. It's using this secret to be able to access the remote clusters. And that's how it's monitoring the informers. And you can kind of see that here. And then, of course, this is the route spec. You can have many routes. All my routes are going to have 125.65. So all the routes that I create, this is going to be the IP address. This is going to be the virtual on Big IP. And you can do many different advanced Big IP configurations through here. So think of this as your gateway. This is what would be created by maybe the Big IP administrator or working with the Big IP administrator. It's different than the routes. The routes are all here. Here are my routes. These are routes. So these are the routes. This is the HTTP routing. This is really the gateway. So that's the concept here. But all of this is created in the local cluster, right? Because that's kind of where CIS is running. So the route and all the cluster manager has to be created in the management cluster, right? So you have to create the routes in the management cluster. That's the only difference here. In the app cluster, the only thing for CIS is authentication, authorization, just to watch. And then, of course, the pods. You can actually see there's the pod deployment right here. So if we go to the local cluster, you can see here's the pods, right? So there are 3 pods of coffee. So if you see the deployments here, there's a couple of deployments. There's coffee, mocha, and tea, similar to our diagram, coffee, mocha, right? So you can see there's 3 pods running. So this is the remote cluster. So let's go back to if we go back to the diagram, let's kind of go through this. In the diagram here, you can see here is the remote cluster, the workers, the coffee pods. And in the local cluster where advanced cluster management is running, where CIS is running, CIS is using kubeconfig to be able to subscribe to these services. And then what it's doing is it plumbs Big IP. So that's kind of how it works. It's actually very simple. And if we look at the route, you can actually see that this route is created. You can see here there's an annotation that basically says for multi-cluster services, the cluster name. So here's the cluster name, and then here's the service. So for example, coffee service It's of namespace, and that's the port. And then you can see here's the standard route. So this is just a standard route that is created. We can see this route if we go to the local cluster and we go down to network, we go to routes. You can see these routes. Let's see, they should be created. I think it's under default. Yep, they're right there. You can see there's the route. If I click on that, we're going to see there's the traffic. You can see we're hitting the virtual, and look at that. That's the server address right there. It's a 148, right? So that's going to the remote cluster. You can see here it's incrementing. That is the virtual. So if you want to use the real IP, that's another demo that I'm going to deliver next. I got asked if I can use the real IP where we don't implement SNAT. And we can do that with ovn-kubernetes by using an external, what we call an external gateway for the return traffic. So I'm going to test that. I'll create a demo on that. But if you go back and look at the route, that's what we see. We see the pods, and we see the 3 routes right here. So this is the routes that we see in the local cluster. And then here are the pods in the remote cluster. Now the goal here is to obviously set up maybe more than one cluster. So in my diagram, I only have one cluster, but I will create more clusters. Promise you. I will add another cluster here. And then what I'll do is I'll use a ratio, or I'll do some kind of blue-green, where maybe it's an active, everything goes to one cluster, and then you can switch the ratio weight to another cluster, but everything's managed. So there'll be 3 clusters. There'll be a management cluster, there'll be worker cluster 1 and worker cluster 2. That's coming. Promise you, that'll be coming. But this is really the goal here. This is really the start to talk about this architecture. Now, this is new, but everything here that you see is shipping. There's nothing here that is not shipping code today. So there's nothing here that is preventing you from building this architecture out. You could totally do this. If you put most of the organizations have a big IP here already. Just need to put CIS in here. You don't have to manage or ingress all of your traffic. You can pick and choose. You choose which service you want to subscribe to. That's what's really cool here. It's not all services. You can use a combination of CIS, HA proxy. There's nothing wrong with that. In fact, that's kind of like, even moving forward, it's kind of like how it's going to be, the whole integration. So pick and choose. You could use a combination of lots of different things. Or you could just use CIS maybe for TCP. It's up to you. Totally up to you on how you want to do this. But this architecture is definitely the preferred method to go for deploying OpenShift, because we see a lot of OpenShift clusters. And so the whole concept of tying them together using RedHat Cluster Manager and the different architectures. So you can kind of see here now what would happen if I go back and monitor this API. This is the AS3 common API that sits within. So anytime there's a change, this API could actually see the change right there. So what happens if I actually go in here and go to the remote cluster and actually go ahead and make a change? So what I want to do is I want to go in here and let's scale some of these pods up. And let's watch how CIS monitors these pods and how CIS plumbs the big IP from the management cluster, because that's what's going to happen. You're going to have a developer, potentially someone with a persona of DevOps, accessing this cluster, making changes, and it's going to be replicated onto the big IP without even touching the management cluster because the route's already in place. So it's pretty cool. Think about if anything happens here. If you have multiple clusters and you do an active-active, your management cluster is completely safe. So let's go ahead and do how about scaling this coffee up? So we'll go ahead and scale this up to, give it 6. Let's scale it up to 6. And so this is a live demo. And so we're going to scale this up to 6. So if I go to pods, and I can see here's my coffee pod, and you can actually see, so here's the IP address right here, 149.2.21. And so I should be able to, if that IP address is there, I should be able to go onto my big IP. And of course, oh, wow, sorry about that. All I'm doing here is I'm simply pinging the big IP. And I'm pinging from the big IP, I'm pinging the pod. Yep, it's pretty small. I know, I'll make it bigger. But I was just pinging the big IP. So I was pinging from the big IP, I was pinging the pod. And you can see the ping is successful. That's the most important thing. And so if I get back here, oh, look at that. There's an update already. So you can see here on the API, because we're watching the API. So CIS has detected a change. And so it's plumbed the big IP. You can see here tenant 200 OK plumbed the big IP. So if we go and look at the big IP and we go look at the traffic management, local traffic management, here's the virtual server. So the virtual server is here. You can see the resources. Here's the policy. And so basically the policy says for coffee, go to the request, go to the pool. This is the pool. So for anything coffee on /, go look at the pool. And so the pool is really important because the pool is going to show us. Look at that, 6. So in this instance right here, here are the members. There's 6. Remember I pinged one of them? So look how nice that is, 148. These are sitting on different nodes. They're spread across different worker nodes. So in that environment, 148, 149, 151, that's 3 worker nodes is kind of where they're spread. That's where the traffic is. That's where those pods live. This is why this demo is really awesome. So what I did was I made a change in the remote worker clusters. Simple scaling. It showed up on big IP with CIS running in the management cluster. So I didn't touch the management cluster at all. I made a change in the remote cluster. It's very simple because CIS is subscribing to the service. It's just monitoring the service. It's something called informers. It's a simple API call, right? That's what Kubernetes is all about. So CIS is using the exact same methodology that Advanced Cluster Manager is using with using kubeconfig. There's nothing different. So I can go and scale this back down again just to keep it clean. We'll go back down to the deployment. Coffee's of 6. Let's scale this back down to 3. So 5, 4, 3. Give this a little bit of time just to settle itself. So you can see coffee's of already 3. So there's 3 coffee pods right there. So OpenShift is already done its magic. And so we go to big IP. We should see, if we do a refresh here, we should see, there we go. Changes already made in the remote cluster. Not even touching the management cluster. Management cluster is really just there for management. Local cluster, let's go to both clusters. Don't have to do anything. Just running nicely, working perfectly. So this is the demo. This is the power of being able to use this environment. Now, talking to the PM from Advanced Cluster Manager, there's a lot that we can do here. I would like to deploy CIS as an advanced configuration. I would love to be able to create the application here. So we got a lot of things that we talked about yesterday, but maybe that's next. Maybe instead of creating a manifest and deploying through manifest, maybe could deploy it as an operator, but I'd love to deploy it as an application set. And that's future stuff. Can totally play with that. If you get this working, please let me know. I'd love to see it. But yeah, you can import the Helm. It's based on Helm. You can use Helm. Let me know. Love to see you guys play with that. But going back here, you can kind of see the overview here. Oops. This is Advanced Cluster Manager through. But you can see here's the clusters right here. So I'm not doing a lot with this, but this is just a start. Just the start. So that is the demo, folks. You can see that if we wanted to click around here, go to this is the remote cluster. So go to back to the routes. There's no routes on the remote cluster. So go to the local cluster on the primary. Go, because the routes are created there. Go to network. That's where the routes are created. That's kind of how it is, because CIS creating the routes there. And so you can see here, if you wanted to go to Mocha, you see that's refreshing. There's Mocha. And if you wanted to go to T, there's T. That's incremented. If we wanted to go to coffee, there's coffee. So coffee, tea, and mocha. And you can see that's kind of how I'm connecting through there. So let's go ahead and recap. Quite a lot there, quite a lot going on. Here's my repo. You're welcome to clone my repo. I'll publish this. You can clone the repo. But this discussion here is how F5 is integrated or working with Advanced Cluster Manager in a management cluster, management type cluster, where there's really no app workload. The only type of workload there is of management type. Really kind of like your networking frameworks, maybe your networking operators, your IPAM, IP address administration, that kind of stuff. And there's plenty more. I'm sure that maybe security posture, that kind of stuff, kind of running there. And so that's where CIS is running in the management cluster. And CIS is watching all of the services that it's told to watch in the routes that are running in the worker cluster. So right now I have one cluster, but I can run many. I can add multiple clusters here. And so what I'll do that next. My next video will be of multi-cluster. It's kind of similar to this, but I'll kind of expand. I'll build out another cluster, another OpenShift cluster. Maybe the 411 cluster I might just add. We'll see. So that is this demo. I hope that you like this. I hope that this kind of like gives you some ideas on kind of what I'm seeing within the community and talking within Red Hat, as well as multiple customers like yourself or implementers like yourself. If you like this, please give a thumbs up. If you're not subscribed, please subscribe. I'm chasing that 1,000, hopefully going to get it this year. And if you have any questions, you can reach out to me via YouTube, or you can contact me on GitHub, or just contact me via my email address at F5. And you have a lovely day. Thank you.